Hello. Can everyone hear me? Maybe. Sweet. So, I'm the guy that people come to talk to when they get frustrated with storyboards, and figured I would share a little bit of that. It's going to be like a why you shouldn't use storyboards. I'll let you figure that out on your own, and then you can come learn from this when you have made the decision to see the path of light. So a little bit about me. I work for a startup. So you can go there or bug me. But anyway, so the first thing you have to do with storyboards is delete them, because Apple doesn't actually ship a template anymore that doesn't have them. And this is harder than it should be, so we'll start there. The first thing you can do, and my favorite part, is delete the actual storyboard. But you then have to go update your info plist to make sure it doesn't try to load your storyboard. You can do this from the General tab, but some versions of Xcode just ignore you and keep it in your info plist anyway. And then, because Storyboard's doing a lot for us, one of the things it's doing is setting up our initial window when the app launches up. So we're going to look for this method in our app delegate, and we're going to start filling it in with a window. Because despite it being a phone, it does actually have a window. You just kind of get one. So it's pretty simple. You're going to create a window. You want it to basically fill the screen, so you can grab the screen bounds. And then you need to set your root view controller, which in this case, it's just a view controller, but we'll get to actual more realistic use cases. And then you have to call make key invisible, which is just an important step that's going to actually activate your window. But once you've done those three steps, you're now storyboard free, and you're back to the starting point that you would be if you didn't have a storyboard at all. So from there, you probably want a navigation controller, maybe a tab controller, any kind of view controller really, but you need to initialize it here. Oh, that's cut off. That's annoying. So if you want a navigation controller, you can initialize it, stick whatever view controller you want to start with in it, and you're kind of off and running at that point. So in storyboards, you tend to just click things. Like, so if you want a title, you click your navigation bar, type in a title. Most of that information actually comes from the view controller, not from the navigation controller. So if you want a title in your view controller, is where you actually need to set that title. And the navigation controller will intelligently grab it. If you push a new one onto the screen, it will automatically grab the next title. You don't have to deal with it. So it's the same thing if you want a button. You need to set your button on your view controller, and then your navigation controller will find it. And it does all the fanciness of swapping buttons and things of that nature. It's very similar for a tab controller, except you give it 2 view controllers or however many. But again, until you give it a title, you're not going to have it. Until you give it an icon, you're not going to have it. But all of those belong to your view controller, so it's easy to swap them out. So let's say we wanted to start with a table view, which in storyboards tends to be pretty easy. You drag it over and you're kind of done. In this, you're going to want to start with your actual table view controller. You can make a regular view controller and put a table view inside of it, but a lot of times this gets you there and makes it simpler. And then this is your standard data source methods. So you were going to do these anyway. And then you have to register your cell, which is, I think if you're using nibs, this is still something you do, but if you're using storyboards, I think this step is abstracted from you with prototype cells. But this is important so the table view knows which cell you actually want to use. And then back to your app delegate, you can swap out the view controller that you were initializing for your table view controller. And now you have a root view controller. It's not particularly hard, which is one of the points I want to get across. A lot of people they learn on storyboards because it is a great learning tool, but at some point, it's good to know how this stuff works under the hood. So I would encourage you to play with it, regardless of if you're actually going to use it all the time. Maybe you go back to storyboard because you feel like you're faster or it's just easier. So this stuff isn't too difficult. So from there, we probably want to figure out how to get more screens going. If we're thinking about our table view, click on a row and you want it to slide over, instead of a segue, you're going to find your delegate method for your table view. And then we just need to tell our navigation controller we want to push another view controller onto the stack. Again, this is very similar to what you're doing in Interface Builder already. So it's not anything that's particularly complicated. So if we want to control our own sort of vertical presentation, then we'll start with a button. And our action for that button, we have to manage. So rather than an IB action that you'll connect to code or something like that, you can set up a target. And then the presentation looks really similar to whatever you're going to do with a navigation controller. You just call present. In this case, I'm wrapping it in a navigation controller so that we get another bar that slides up. And then this is all that settings view controller at the moment is. We still give it a title, we still give it a done button, and then as far as closing, we can call dismiss. Technically dismiss will dismiss whatever's currently on top, so if you had presented another one, it would dismiss that one, but most of the time the one that's calling the method is the one that's already on top. So all of these view controllers have been very boring so far, and this is, you can't get past code without learning a little bit about auto layout and more about how it works. You're already using auto layout in storyboards, but if you haven't dove deep into what constraints actually look like and sort of how they work, then you can be missing a lot of the power, and this is good stuff to know even if you're still going to maintain storyboards. So we're going to take a way brief step back and look at what actually happens when you drag a view into Interface Builder. So you get a view. It's now a sub-view of the view controller's default view. And it kind of gets a position of its own just because Storyboards or Interface Builder itself will give it one. And then you might set its background color. Yeah, so really basic. We're going to look at how we would do something like that in code. So you're going to start with your view. This is essentially, this is creating your view, and then when you add it as a subview, you've replicated that first step of dragging it out. This is the 2 lines of code that Interface Builder is doing for you at that point. But we still don't have a position, so we have to do that ourselves. If you're not familiar, we're 0, 0 in the top left corner. And that's mostly the most important part to think about. So when we set up a frame, and this is not auto layout, but when you set up a frame, if you keep that in mind, you can really specifically lay out your views if you want to, and you'll be in the same spot. We can't see anything because it doesn't have a background color yet. So that's what it would have been doing. We've moved on to auto layout since then, so we can take a look at that. Constraints. I mean, you probably know what constraints are at this point because you've been using Interface Builder and you kind of have to. But it's helpful if you think of constraints more as rules or guidelines than your actual sort of blueprint of your app. I mean, it's really common if you're working with designers. They're not going to mock up every device because it would take way too much time. So they're going to give you one, and if you treat that as a blueprint, you're going to end up with problems on other devices. So it's better to look at it and try to come up with what rules were they thinking of when they designed this. And if you talk to them, they'll probably tell you because they've put a lot of thought into it already. And then constraints affect horizontal and vertical. It's just helpful to get your mind wrapped around that you have to sort of figure out one before you can figure out the other. It wasn't always true when you were dealing with frames and stuff. So we're going to look at the same really simple example. If we don't need a frame, we do have to make sure we turn auto resizing masks off. If you know what auto resizing masks are, that makes sense. If you don't, you just need to know it's the way that we used to do it before auto layout showed up. So then this is the constraints to actually do the same thing that that nice simple frame was doing. And this is a good reason why people stay away from code and go to storyboards, because that's a lot of code. But we're going to work to shrink it down. So if you're not familiar with constraints, then you start with an item. In this case, it's our block. And then you can choose sort of what they call attributes, so left, top, bottom, how you want to relate it to maybe its sibling or its superview. And then in this case, we're setting it the left equal to the left of our superview by 50 points. And then we make that constraint active. So this just replicates that frame, that's all it does. But this is where we run into, we didn't really think about these constraints as rules. We just replicated our frame. And so on a larger phone, if you wanted this left align, you're done, but you probably don't. So if you change the third constraint, I probably should have highlighted that, simply by thinking about the width in terms of padding rather than the width itself. If we set the same padding on both sides, the system is going to handle calculating the width and then setting that for us. And under the hood, all AutoLayout's doing is performing this equation that we've set up, and then it shoves the frame in that we could have done on the beginning. So these aren't particularly new ideas that AutoLayout sort of pioneered. If you were doing frame math 5 or 6 years ago, you were probably doing this already to make sure that your app worked in various landscape and portrait. Maybe you had an iPad version. This just sort of brings a lot of structure to it. So then, similar thing, we could keep the width fixed and instead center it. Just sort of a different way of thinking. It's kind of, if you're sort of new to this, if you can wrap your mind around what you wanted to happen, then there's probably a way to write simple code that actually, specifies your rules to the system. So, about all that code, in iOS 9, they came out with a thing called layout anchors. And they still create constraints, but they look more like this. And so this is that same code that's sort of replicating our frame that we had set up. But this is obviously a lot less. And most of that is because a lot of the information when you created a constraint, it was fairly, it was just wordy mostly. This makes it a lot easier. So this reads pretty nice. You can say, block, center X, we're going to create a constraint that's equal to our superview, center X, then we're going to activate it. So it's a good bit of code for what was one line of a frame, but it's at least readable. So when you're thinking about anchors, you have a lot. And some of these are sort of similar. A leading anchor and a left anchor in most practices are the same. They're technically different things, but almost all the time they'll be the same. And you'll see that you have sort of x-axis anchors separate from y-axis anchors. Those are the same for every method that you're going to call. The two NS layout dimensions for your width and height, they get a special little ability to where you can set them directly to a value and completely skip making it relational, which is what we were doing before, but we still had to specify a nil item, and we had to specify we didn't care about relating it to anything. So this just simplifies that and lets us set it directly. And these are some of those, what those look like. You can create a constraint. You could create a constraint that's greater than or equal to. And we'll talk more about what those actually look like. But these are just some of the methods that you can play around with. You can still set constants. So like when we did 50 points from the left to the right. And then this is for the NS layout dimensions where you can set it directly to a value. And you can still do greater than or equal to, multipliers. Anchors are not weaker than constraints. They're just, mostly they just have more sane defaults. So thinking back to, that's a lot of code to replicate what was one line of a frame. If you're probably familiar with intrinsic content size, we're going to go through it really quickly. But intrinsic content size is, think about like a switch or a slider or an image. It already has a size sort of associated with it. So we don't necessarily have to give it one. And if you lay things out more relationally, you can let it sort of default to its own sizes. So if you think about switches, they're always the same size. They have a very fixed width and height. And if you, even in Interface Builder, if you drag one out and try to change it, it ignores you and sticks with it anyway. Then you think about a slider, it has a very fixed height, but it doesn't really care about its width. So an intrinsic content size doesn't have to be sort of fixed. It could be a little malleable. And if you think about an image tends to have, it normally has a size associated with it, and iOS does a good job of, if it's a 2x or a 1x, treating those as the same point size. And then labels are a little tricky. They do have intrinsic content sizes, but only if you give them a fixed width, which makes sense, but if you're not paying attention, sometimes they can run off the screen. So we're going to look at a little bit of what this looks like. It's mostly these two things. So you have your intrinsic content size. Every UI view has this, and if you make a custom view, you can override this and return whatever size you want. And then if it's something like an image view or a label, something where your custom view has content that can change, then you can invalidate it anytime the content changes, and auto layout will just update the view, and it will save you a ton of time. So even things like if you've ever used a UI button and you've set the title edge insets to try and get you a little padding on your button, it ignores them in its intrinsic content size. So if you subclass button, you can override intrinsic content size and make it respect those title edge insets or the image edge insets, and then your button will respect your auto layout as well. And then if it's something, so think about the slider again, it doesn't care what its width is, so it would specify this in the width section of your size. And this just tells the system, I don't care what size I am, stretch me, squish me, it'll be fine. But the coolest part of intrinsic content size is by default, a UI view will try to calculate its intrinsic content size based on the views that are already inside of it. Its subviews will dictate what its size is if you let them. So if you set up like, you've probably done this with dynamic sizing table cells. The way they're figuring out the size that they should be without you having to explicitly set it is the intrinsic content size is measuring what each value should be for your label, maybe you have an image, and then it takes the intrinsic content size of the cell, and that's how high your row is. So we can replicate this in all of our layouts. This works for your views, works for custom views. If you're literally just laying out a UI view with a lot of subviews, it'll figure it out. And it takes into account your auto layout, sort of, if you've got padding and stuff in between, it takes those into account too. So it can save you a lot of code in that fashion. So then that brings us to visual format, which is, it gets a lot of hate. If you've ever Googled visual format, you probably find a bunch of blog posts talking about how awful it is and all the things Apple could do to make it better. But I actually like it a lot, and I think it makes things pretty simple. So visual format at its core is just an ASCII-based string with a few rules that it can use to create a lot of constraints automatically. So this one line, actually, I think it creates 12 constraints. So we'll talk a little bit about what this looks like. So the first letter of every string is either H or V, and that's just telling the system, is this going to be a horizontal set of constraints or vertical? Then the pipes that are around it represent your super view. So in this case, our image view is pinned 16 points from the edge of its super view. And then the 16 points are just metrics. They can be fixed numbers. They can be named values if you provide a metrics dictionary, which is very helpful for keeping those type of values the same across all of your apps. The metrics can be greater than or equal to, just like our anchors, just like our constraints. And then the actual views, they're just represented by their names in square brackets. And then you can even give your views very specific sizes inside the square brackets, so we can specify this is going to be 44 wide. And then even those can be greater than or equal to, or less than or equal to. And you can even set them equal to other views, just like regular constraints, except we've managed to do all of this with one string at this point. We've specifically said we want our margin to separate our super view from our image. Then we've said we want our image to be exactly the same width as our title. We want some padding between those two. And then on the right side, we actually want greater than or equal to margin before the super view. So you can imagine this whole set of views being left aligned because the margin on the right is the part that's going to stretch. So this is, if you're wondering where the names came from, this is what working with visual format actually looks like. You're going to create a metrics dictionary. Well, you don't have to. You can just use the hard-coded numbers. But you do have to create a views dictionary, which just maps your actual views that you want to lay out to names that are going to show up within that visual format string. And then because this is meant to be more of a readable thing, that's the benefit of this, is you can quickly read this and kind of picture in your head what this is supposed to lay out to. So I like to shorten my names to something actually readable. So if you read this one string, you get a very good idea of what's going to show up for this view. You know the image is going to be on the left, you know the title is going to be on the right, and you know that you're going to get the same margins on both sides with a little padding in the middle. And this is creating a lot of constraints for us. So these are the two lines that we would have to write to sort of replicate that frame that we were creating before. So we're creating, in the horizontal space, we just want 50 points of padding on both sides before it hits the edges of the super view. And then on the vertical, we want 50 on the top, and then we want to very specifically fix it to 100 height. And you'll notice there's a pipe missing on the vertical because we don't care what happens underneath. We just want it 100 high, and it'll stop. So this looks a little nicer when you have to deal with multiple views. So in this case, you can imagine, remember we had 8 lines worth of NS constraints on their own. We had 4 lines of anchors. So if we were going to lay out 3 views, we'd end up with 12 lines. And this method's ridiculously long, so I guess you still end up with 12 lines. But you get a visual picture of what you're dealing with for your, all the horizontals are the same, and then vertically you can lay them out together in a single set of constraints. But you've probably gotten tired of looking at it, so I tend to use a little extension, which just makes the options optional, and it makes the metrics standard across the entire app, because I always want my margins and padding to be the same. So if that interests you, you can bug me and I'll share it with you. It's not particularly complicated. It's just a single method that redefines that and then activates them for me. So this is normally what I'm looking at. But in a situation like this, you're probably going to want to use a stack view. And I'm sure you use stack views in Interface Builder because they save you from dealing with constraints there. They'll save you from dealing with constraints here. For those of you not familiar with stack views, they're a view type that doesn't actually render on its own. It just holds other views and stacks them. You can manipulate its axis, its distribution, which is sort of how the views get stretched and laid out. You can deal with alignment. So like on a vertical one, that would be left and right, but on a horizontal, that might be top to bottom. And then spacing between your views. Then these were your various distributions that you can set with. Fill would stretch them all. Fill equally will make sure that they're exactly equal heights in this case, since it's vertical. Fill proportionally would be based more off of what their actual sizes are meant to be. Sort of going back to the intrinsic content size, that's what it's going to base it off of. Equal spacing will try to make sure that the actual physical spacing between each view is equivalent. And then equal centering is really interesting because it will find the center of each view and then use that to make sure that they're equally spaced. So it's sort of more of a visual centering, which you often get. It's really important for if you have several icons side by side. A lot of times your designer has given you specifications to try and make them look like they visually are centered, but in reality, if you tried to center them, they wouldn't be. Apple thought of that because Apple likes designers. And then alignment is really what you think, except that they have specific ones for dealing with labels and horizontal setups only. So if we think about that small little example, this is what our stack view ends up looking like. And we only have to worry about the auto layout for our stack view because the stack view itself is going to worry about stacking our views. And this is about the same amount of code, but you can imagine this is quite a bit easier to read. And then we'll come to a point later where it's really helpful to have things in a stack view. So thinking back to our table, if you had set this up in Interface Builder, you would have gotten a prototype cell, and you would have laid it out manually in Interface Builder. So we're going to create a cell. You're going to start with your actual cell subclass. And in this case, it's very important what your init method starts to look like. That's where we're going to do most of our setup. And we're going to make sure we update our registration on the view controller, so we're using our cell. And then this is the only place you're allowed to use an exclamation point when you're writing Swift. It's when you dequeue a table view cell, and then you have to force it to know what type it is because they haven't implemented generics yet. So then, in our table view cell, you can sort of picture, we're going to put an icon on the left side, and then we're going to stack two labels for the most simple generic table view cell you can imagine. So we have to create those views since we can't just drag them onto our table view cell. So what this is doing is creating lazy properties for each of the types of views that we want to deal with. This is helpful for a couple of reasons. One is organizational is probably most important because now all of your views are specified individually in your code. So if you want to change a label's font, you can do it for that label, and if you need to know what a font is for a label, you can command click on your label in your code, and Xcode is going to take you straight here so that you can see. But then it's also nice from a performance standpoint because these views will only be loaded when they're necessary. In our case, that's not going to be all at once, but in a lot of cases, especially if you're animating views in and out, then it can save you from having to initialize a lot of views all at one time, right in the middle of your view did load. So if we're going to set those views up, we're probably going to use a stacked view. So if you imagine our icon on the left, and then we're going to put our labels on the right, and we know we want our labels vertically stacked, so we can stack those in a vertical stack view, and then we only have to worry about getting the group of labels to one side and the icon to the left. And we'll set up our view dictionary. So then right underneath that, we can worry about what our actual auto layout's going to look like in visual format. Horizontally, it's very similar to what we were dealing with before. It's an icon on the left with a little bit of padding, and then our labels as a group, because they're in a stack view, on the other side. And then vertically, we just want to make sure that our icon and labels have some padding above them. And we use greater than or equal to here so that, imagine if your detail label had 2 or 3 lines of text. You probably want to make sure that the label can stretch one way or the other, and you want to keep your icons and your labels centered. And then we write the actual anchors to make sure that those views are centered at all times. And so this is probably the level of mixing that you're going to get to most of the time, is you can do a lot of visual format, and then for 1 or 2 things that are very specific, you can write an anchor. There are other ways to do this, but normally this ends up being the simplest way with the least code, that if I come back to this in a year and I read this, it makes perfect sense. And it doesn't conflict, because if you think about centering an icon and it's got greater than or equal to padding on the top and the bottom, then it's okay to stretch that padding so long as you're forcing it to be centered. So then this is what we end up with if we run that code. Not exactly what we were looking for. It's close. The icon's on the left. But now we need to talk about another aspect, the compression resistance and hugging resistance, or hugging priority. So content hugging is what we're going to use in this case. And this exists in Interface Builder as well. But this is, in that example where we have this, we don't want our icon to stretch. We do want our text to stretch. So we can set the content hugging priority to high, or we can also set it to required if we want for our icon. And that's going to force it to try and stay close to that intrinsic content size. And as long as the label has a lower content hugging priority, then the label is going to, it's going to give up on trying to stick to its intrinsic content size, and it will stretch a little bit. And then you can set these for horizontal and vertical and treat them separately. And then content compression is the exact opposite. Content compression is when something's trying to get squished. So like maybe we type a whole lot of text, and now it wants to compress our image. Well, we can set this to a high value or a required value, just like the other one. And this is going to make sure that it tries not to get squished smaller than its intrinsic content size. So you can imagine if you set both of these to required on, say, the image, then the image is going to basically be its intrinsic content size. It's never going to stretch, and it's never going to squish. It's going to leave all of that to the label. You can set these values to numbers, if that's helpful. I think low replicates to 250, and high is 500, or high is 750, and required is 1,000. So if you have a ton of these views and you need to set a lot of priorities, you can literally just do 251, 252, 253, and it'll work. But for the most part, you can stick to these specific values. So we go back to our image view that we had set up, and we can set the content hugging priority to required. Now our icon's not stretched. So we have a new problem looking at the text being cut off, and that's because of the table view cell is not respecting the intrinsic content size of the cell itself. And Basically, the only thing you have to do is set the estimated row height. You should try to set this to an actual estimate because it uses this when you're scrolling really quickly to set those frames very, very fast, and then it goes back and updates them. So if the update is way bigger than what you'd set for the estimate, and you're scrolling really fast, sometimes you can see cells kind of popping. But for the most part, if you set it, now the table view knows you don't really care about what the row height is. You want it to figure out what it's going to be. And the way it's going to do that is with the intrinsic content size. So if we turn that on just by setting it to a value, then now our rows are using the auto layout that we wrote that said that vertically, the titles have to have padding on the top, padding on the bottom. And so that's the contributing factor here that's stretching it. If we got rid of section, it would probably be the image that was actually contributing, because the image is probably taller than a single line of text. But all we have to worry about is laying out our view the way we want it, and then the heights are going to take care of it because of the intrinsic content size that's automatically calculated. And this is true in storyboards as well, but it becomes really helpful and you appreciate it more in code because every time it manages to work, it's less code that you have to write. And then this is just showing, let's say we wanted a lot more padding between the titles. We didn't have to change anything except the one value in the middle of our labels. And this is going to make sure that that padding is increased. And then this, notice we're swapping labels and icons. So that just throws our icon on the right. And I don't want to pick on storyboards too much, but if you had to move this icon to the right side of your table view cell, when you did that, every constraint that you would set up in that label is gone or broken. And in a view like this, it's not too complicated to go and set them back. But in code, it literally was swapping those two values in this string. That is all we had to do because all the other layout was still valid. We still wanted them vertically aligned. So it's really nice. And then these are all the things that I really wanted to talk about, but could not find a way to cram into this talk without it taking forever. But I would love to talk about these things more. So if you have specific questions about any of this, bug me tonight at the Game Jam or tomorrow, or hunt me down on Twitter, because I would love to talk about how to write better code so that your layouts are closer to the vision that your designer had, and sort of something that is going to work on all devices. Like the coolest thing, we're probably getting a new iPhone. It probably has a different screen size. So it'd be really nice if you just compiled your app and your app worked, and that is it. And if you've done a good job with your auto layout and interface builder, that's going to be the case. And if you've done a good job with your auto layout in code, it's also going to be the case. But these are some of the things that you're going to run into when you're dealing with code that are helpful. We can talk about them. If you bug me on Twitter, I might write a blog post or something. But I love helping. These are a few frameworks that can make auto layout in code a little bit less prickly. Most of these do something along the lines of overriding operators so that when you work with your layout anchors, you could say width anchor equal to other width anchor. Or you could say height anchor equal to 50. And you don't actually have to write, that's the literal code, you just write the equal sign. And it's nice. Anchorage is literally just overriding operators, so it's pretty lightweight. SnapKit uses some of its own types, and you set them in closures. Masonry is sort of an offshoot, and then pure layout is similar, but it'll allow you to do things like pin all four sides at one time with one line of code. So a lot of people who do things in code, they like to do it this way. I tend to stick with visual format and vanilla auto layout because it's not that hard once you get used to it. I mean, for the table view cell, we wrote 5 lines of code and the whole cell was laid out. So it's not that hard. These might make that 4 lines of code, but now you're dependent on someone else. But if you get into it and it's really annoying and bugging you, try some of these. And that's it. That's my Twitter, if you haven't quit after Mike's talk. But I'll be there. You can ask me questions about this stuff. I love code. Interface Builder's cool, but code tends to be more fun for me.